A flame test is an analytic procedure used in chemistry to detect the presence of certain elements, primarily metal ions. It is based on each element's characteristic emission spectrum and the color in general, which also depends on the temperature of the flame produced. Carrying out a flame test. First of all, samples are usually held on a platinum or nichrome wire, which are cleaned repeatedly with hydrochloric acid to remove traces of previous analytes. Hold the wire over a Bunsen burner flame and repeat until the wire does not produce any color. In the case of a nichrome wire, an orange color will still be visible to the eye. When the wire is clean, dip it again with hydrochloric acid and then into a small amount of the salt that you are testing. Unlike before, the purpose of the hydrochloric acid here is to allow the solid to stick onto the wire. Place the wire back into the flame again and observe. If the flame color is weak, dip the wire back in the acid again and put it back into the flame as if you were cleaning it. This often produces a very short but intense flash of color. Now, let us observe the colors produced by the common ions. Lithium. Lithium produces a red color. Sodium produces a strong, persistent orange. Potassium produces a lilac or pink color. Rubidium produces a reddish-violet color. Cesium produces a blue-violet color. Calcium produces an orange-red color. Strontium produces a red color. Barium produces a pale green color. Copper produces a blue-green color. This is often observed with white flashes. Lead. Testing for halide ions. The solution is first acidified by adding dilute nitric acid. This reacts with and removes lingering ions. Add silver nitrate, then divide it into two portions. Add the first portion with dilute ammonia, while the other with concentrated ammonia. At the addition of silver nitrate, the reactions will show a white precipitate for silver chloride, a cream precipitate for silver bromide, and a pale yellow precipitate for silver iodide. Upon the addition of dilute ammonia, only silver chloride will dissolve, while silver bromide and silver iodide remains in a precipitate form. Upon the addition of concentrated ammonia, silver chloride and silver bromide will dissolve, while silver iodide remains in a precipitate form. This thus shows the solubility of each ion. Thank you for watching. We hope that this video has been informative and useful for your future needs.